Okay, so we're going to cut out these clamps here, and this is what they look like here. So we're going to cut them out like that. So I'm going to just rough out a hole with this just to get a good hole started. This is 1.5 inches. And they end up, well, actually they're two different sizes, fairly close to 2 inches, 50 millimeters, somewhere around there. And I got my stop set here. Now, there's a little problem with this that I just wanted to kind of highlight here. So this is the shape that we're cutting out right here, and the idea was I'm going to smack a hole through the middle there, and then use the boring head and cut that out to the right diameter, and then I'll come with a end mill along the side here and just make that nice and tangent. So that's all fine and dandy, but this is a crappy setup here. The problem is when I pop through here, now it's a horseshoe shape, right? So whatever clamping force I have on the part, it's going to relieve that pressure. So I'm squeezing in, and as long as I have two sides, it's nice and strong, right? And it maintains the force, but when I remove one of them, it's going to relax a little bit. And in machinist terms, it'll go to crap pretty quick. So we'll change the setup a little bit. What we're going to do is we're going to put it like this, but the problem with that is I don't want to cut into my vice jaw or wreck my tool, so I need something sacrificial to put in there. So I cut this little piece of aluminum here, and now don't worry, I'm going to take the parallels out. I'm not going to be able to use my stop here, and in reality what I really want to do is kind of move to the middle of the vise anyway, and kind of do it out in the center of the vise instead of towards the edge. Now these things are pretty good, but they still, they still have the potential for cocking slightly, so if you have a choice, the center's just a whisker better. So excuse me. Here's the, I'm going to lay this on top here like so, and we're going to be cutting into that. So I think what I want to do is I want to kind of pre-relieve that a little bit in that area. So I'm just going to sketch a little bit by hand to kind of pre-relieve that. When I'm using these, they can do weird things when you have the slug breaking loose in a situation like this. So a round slug can turn, right? But this is a D-shaped one, and this one isn't going to go with it, right? So there's a potential there for an oh shit. So anyway, I'm just going to go over to the bandsaw and just kind of pre-relieve that and get it out of my way. So yeah, that'll work. Okay, I think we're ready to go here. My camera's a little too close there, I think. I do want to keep it. Back it up a little. That'll be better. You don't got to see that close, right? So that's an 1.5 inch hole in a few seconds there. Now that's a Rotabroach annular cutter there. You got to be real careful. It's got a. I'll show you the slug here in a sec once I get it out of there. It's kind of warm right now too. Normally, you know, if you got the right tool for the job, just use it, right? So there's the slug. And you can see it's got this razor sharp little edge on it when it breaks through. So you got to be real careful when you get them out of here. When you use these in the regular Rotabroach machine, they have a little ejector that shoots the slug out of the bottom. And when you use them in the mill like this, you don't get that. But you can see it's pretty efficient. And when you're you can say, ouch. So that's hot, by the way. You got a little slug here that you can use for something. So us guys that are scrounges kind of keep that stuff and throw it in the bin and use it for something else. All right, so now I'm going to go ahead and swap this for the next one since it needs the same thing, and then we'll get the boring head in there and. Open that hole up to size there. Actually, let's try this other coolant here instead of the oil, and see if it behaves itself. Okay, I like that better. Makes a lot of chips, but okay. So 1.5 inch Rotabroach. All right, we got the boring head set up here, so we're going to bore these. Now here, I got to start being a little bit careful because these are two different diameters. So one is 1 inch 854, and the other one is 1.908. And that's because there's different diameters on the bottle jack that they have to interface with. So I'm going to start with the small one, which is 1 inch 854. and this is just a reminder to me. I'm starting with a smaller one because if I screw up and overshoot, which is the only possible way to blow it, I can still use it for the other one. I get a second chance. So this is what I call a tactical approach to certain kinds of machining jobs. Anyway, we'll go ahead and make sure my blocks are out of the way there. The only other thing that's a little bit weird is we have this open situation here, but with the boring head, it should be okay. We're not going to be taking out big hunks there where it's potentially going to snag. So let's see what happens here. The camera's really close to this thing here, so you know what? I'm sorry, guys. I'm going to back that up. I'm just not cool with that. Not have to be that sneaking close, right? Let's try that. That's better. Then I can work without blowing it here. I need all the help I can get, right? So put a little oil on that. All right. Raise the feed, Mr. Feed. That's just taking a little skim cut in there right now. I don't have a stop set. I'm just going to watch it manually here. Like that. Come up out of the hole. And then I'll make a boring head adjustment there. Let's try that. Huh. I wonder if my insert's jacked up. Oh yeah, it is. Okay. So the insert's chipped, and I was watching it go down and cut, and it was leaving a really crappy finish. And then when I came back out, it was cutting on the backstroke really heavily. So to me, that's an indication that there's a problem with the insert. So let's go ahead and swap that out. I gotta go get a Torx. Alright, so I got the insert out, and yes, it's chipped. I might have bumped it putting it away in the drawer over there, and dinked it. So always clean the pocket out. Make sure you're clean on the pocket, and then try not to lose the little itty bitty screw. Many years ago, I was changing an insert in the CNC lathe, and in the middle of a job, no less, of course, right? And it was it was a weird boring bar that we had, and I dropped the frickin' screw in the chip pan, and it's full of chips, right? So immediately I stopped the chip conveyor, and I'm looking, and I said, okay, well, I'll just I'll get another screw. Well, we didn't have one. We had a bunch of spare screws, but we didn't have one for that particular bar, and so that was the pits, right? So I went back and looked and looked. Anyway, after about an hour and a half, I found the damn screw. I had to clean the whole chip pan out, and I found that screw. I was so proud of myself, and so immediately after that job was over, I ordered a couple extra screws for that particular bar. Never needed them again. But every time I change a screw in a situation like that, I think about that, and so I try to be real careful. You know, it's not going to go anywhere, but still, you know, you can, excuse me, stall your job for a little while. All right, let's see how that works. Oh yeah, much better. You can hear it. It's cutting smoother. You can see the finish. It's just, it's proper. That's 5 thousandths per rev feet, I think. And I think it's going to be fine for what we're doing here. We got a ways to go. So this is going to be pretty boring, get it? And so let me whack on this a little bit, and then I'll come back and I'll show you guys the finished stuff. All right, so I don't want to brush those off yet. We did the first one to the 1-inch 854, and I was using this other boring head here with the carbide insert, but I noticed this particular type of interrupted cut was playing havoc with the inserts there. It's coming on to a very fine edge right here, and for whatever reason, and I don't quite understand it, but the inserts really weren't liking that. You know, normally you can take an interrupted cut with a carbide insert and it's not really a problem, but I think it had something to do with this kind of knife edge approach here on this side that was giving me some trouble. Anyway, we got that to size. So what I did is I switched to a different boring head, and this particular one, this is a high-speed tool here, and high speed is tougher than carbide. So when you have a bang 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 or some interrupted cut that's causing inserts trouble or whatever, switching to high speed a lot of times will get you out of trouble. And you can see here, these are the chips from, I'm down to the last bit here, there's one more cut left, but you can see these chips are they're textbook chips here, right? They're really nice. And I was taking let's see, this one, so I got to be really careful because this particular head here reads direct, 1 division is 1 thou, and this one, 1 division, it's radial. So if I dial in 1 thou here, I get 2 on the diameter. So that's what I call 1 to 1, and so switching between these can be hazardous to your part. Anyway, so the dial reads 50 thousandths per 50 divisions per rev, and so that's 100 thousandths on the diameter, right? And I was taking 100 thousandths passes there, and I slowed the feed down a little bit too, and that seemed to help. Anyway, this last cut is about a 40 thousandths on the diameter, about 1 millimeter on the diameter for our metric viewers. And so I'm going to dial in half of that on the, and you see I just put it in neutral just to get it conveniently aligned for my use. And there's 21. All right, let's go with that. And then what I like to do is I come down and I touch the tool to the edge and I feel it. It wants to stop right there. Then I back it up just slightly, and then put a little pressure on the quill lock, and now I can brush my textbook chips away. Fire it up, a little oil, engage the feed, and off we go, I think. Hello. There, yeah, it's going. It's a pretty slow feed. I can't remember. It's 1.5 per rev or something. I don't remember now. But it's cooperating. The chips are looking good there. So I brush a little oil on the leading edge that takes it around to the backside. And if I did my math right, this should be the last cut on this. And the finish looks pretty good down there. And I'm not going through inserts. I don't have that many of those inserts. I got to get some more for the boring bar, the inserted boring bar. What's nice about it is you don't lose your setting when you swap inserts and stuff. So. Okay. Take the feet out. Now, since this is the last cut, I'm going to stop it. And the cutting edge is below the bottom of the part. So I'm going to rotate it around to the clear area there, and then retract it. That way I don't leave a line in the bore. It's just a habit. All right. So put that on that side for a sec. And then we'll get a measurement here, and on this one this is our larger one, our larger clamp that we're making, and we're looking for that 1.908. Let's see what we got here. $9.10. Yeah, 910, 911, something like that. Let's try that again. So you see I'm putting that in at an angle, and then I lock the little thumb screw, and then I pull it through the bore to the center line, and it finds the center, and then I get it out. So, hey bud, what's going on? Yeah, 911. Hey, bub. What's going on? It's Ernie the shop dog. Okay, so I think we're happy with that. And now we're going to set up to do a little side milling there. So, okay, so now what we're doing is we're making these straight cuts on the side, and so this is of interest. And it's a common problem in manual machining in a situation like this, to make this real tangent with the quadrant of that circle, and not have a little notch there and have this all right to the right size. So you can go to the numbers, but a lot of times that kind of lets you down a little bit because of errors in the vise, or maybe there's a width problem and the pickup wasn't very good, but trying to get a nice tangent there. So what I'm doing on these, and I'll show you guys, we'll get this one in here. I did one already, and I said, oh yeah, you know, that's a good one. So we're gonna set that in there, get it clamped in there real nice. So what the first thing I want is I just want some guidelines. You know, these are the Bozo lines here, right? That, you know, when I'm getting close to the line, start paying attention, you know, that kind of a thing, right? So these are just little scribe lines here, and I'm, you know, putting them on there kind of as accurately as I can. You can do this and bring this up to the edge real nicely like that. And then get a scribe in there. So what that tells me is, you know, when I see the cut approaching that line, it's like, okay, start paying attention and look at the numbers, right? So we are going to be looking at the numbers. And so the way this works is, when this is on the center of this circle, right, and let's see, what do I want to say here? And its tangent, it won't cut into the side. So I know what my distance is from my datum here to the center of this circle, which is 690. And so as long as I don't back up past that, okay, where the circle's coming back, I won't bite into that surface, right? So I'm never going to go beyond 690 this way. So I'll just keep whittling away at this, whittling away with it. And then when I get right down near the end here, I will come up to the 690, and trim that edge, and but very carefully. And if the sound's good enough, you'll be able to hear what I'm listening to get this to come out nice and tangent. So let's get ready here. All right, let's drop this in. This is just 1/2-inch carbide end mill. I don't even care what size it is. And that's one of the problems with doing the math method is, you know, this is this particular one's a regrind, but even an on-size one, if it's running out a little bit, a couple of thousandths, which it could easily be running out that much, or even a 1/2 thou, you know, that cuts the thou over, right? It's pretty easy to leave a little shark, you know, a shark bite in there, or a little witness mark that you don't like. So let's go ahead and do that. We're going to drop it down in there below the surface, and then I'm gonna. Well, the other thing I'm going to try is I'm opposed to zooming typically, so let me. I'm just going to try it here. This is an experiment. That's about it right there for the zoom. Let's see how that works and how it looks on the video. So I'm just going to whittle that little tip away. So you can hear it, the cut's getting longer and longer as I go out to the So I'm listening to it. Okay, so I'm pretty close to the line now. I'm going to take a cut. All right, I'm going to come up. I'm coming this way towards my 690, but I'm not going to go to the 690. Something less than that. Then I'm going to drive the X over, and you hear that? It just touched, okay? So then I'll take a cut. Then I'll come back, and then I'll get a little closer to the 690. So that's 600 right there. Now I'm going to move the X, okay, and it just touched. Take a little pass. So I'm working both. Okay, let's go to 650, something like that, or 630. 630. Okay, and it just touched. All right, now 650. Now I only moved it 2 thousandths and it touched. Okay, so this is very sensitive now. Because we're approaching the quadrant of the circle on 2 axes, it's the sensitive part of the sign. And all right, so there's 670, and it just touched. I moved it 1 thou. All right, I moved the X 1 thou. Okay, so now I'm going for my 690, or maybe a thou less, 689. Now I'm going to listen very carefully. Okay, I heard it touch, and I only moved it 4/10 on the DRO. I'm going to take a pass, and I'm going to. Well, you know what? Just for fun, let's go all the way to the 690. 80. Okay, 690. Okay. Anyway, that's it. Yeah, that's a good idea. Stick your finger in there, Tom. Okay, so I detect no bump no transition. It just smoothly goes into the curve. Your finger's pretty sensitive on stuff like that. And then we'll whittle away on the other side, and we're going to do the same thing over there. I don't want to take this one out now, but you can kind of see this one here that I did before, okay? And you got a nice transition there. All right, so we got our little pieces here. I'm going to use a little trick for simple layout. I want to bandsaw. This is our curve here. We just cut out the middle here, and now I want to cut out the outside. I want to profile that outside. Well, I don't really want to machine it. Doesn't need to be. I'm just going to bandsaw it and belt sand it. So what I'm going to do is clean my parts here a little bit of acetone, clean the steel, and then what I did was when I drew these, they're drawn accurately, and what I did was when I plotted them, or when I printed them at 1:1 scale, which these printers, they're pretty amazingly accurate. So this will be fine for a bandsaw template. So what I'm going to do is I'm just going to stick these two right on the parts and use them for a template. And I'm using this. This particular stuff is repositionable, so you can peel it off. And it makes cleaning or getting the template off easier. You can use the 3M77 too, works pretty good. But it's harder to get the template off. Now I don't want glue all over the place, so I put the paper down, and then make sure I clear the nozzle on that. Let this dry for a second, I think is what it's supposed to do, yeah. Let the adhesive dry 5 to 10 seconds, yeah. Okay. So I've cut the, so I'm just going to line up my datums there. That. Can you see this thing? Yeah, okay. And carefully pat this. Oops, that one moved a little bit. Okay. Pat that down. Okay, and we'll set that aside for a minute. So all I care about is that outside perimeter. Okay. And then I'm just going to go over to the bandsaw and follow that line, get close to it, and then we'll belt sand it, and those clamps will be done. Okay, so you can see that belt sanded all the way around. Now we're going to just get that off of there. And I'll do a little deburring on that. To finish it up. All right, we're getting down to the wire now. So the last part to make is the these little clamp halves, and we're going to cut a little fish bite out of there. So here's the setup here. So a couple weird things here. So we got it on parallels here, and because we don't have much surface to square it up to. I got a 1, 2, 3 block there and a stop. And so we put it in and hold it up against the 1, 2, 3 block and then clamp it nice. And that acts like a little square. I don't really need to indicate these because it's a circular cut. It'll be fine. But now what we have to do is we have to set this to the correct radius for cutting the other arc out. And I mentioned earlier that these are 2 different radiuses, so the boring head was already set for this particular one because I bored that hole. So I went ahead and cut that one, but I'll show you how to set it for the other one here. So I've picked up this edge. I know where this edge is, and so I know where the spindle center line is. And when it's at 0, it's over this edge. So I know where the arc center is, which is at it's at 750. And so what I'm going to do is I'm going to back this off the amount equal to the arc radius, okay, which in this case is 0.929. 929. Okay, and then we're going to drop this down, and you see that that's, I backed it off already, so it's not touching the part. So I'm just going to dial this in till I get close here, and then I'm going to use this paper as a gauge. See if I can do this and not bump the camera. So I'm just swinging that through an arc and adjusting the board. Okay, it's just catching the paper now. So it's just, see, it's holding on to the paper. So what that means is that tool tip is about 3 mils off of that surface. So now what I can do is look at the dial, and remembering that this is moving in radius, I'm going to move that 2.5 mils, something like that. Okay, so now that should leave a little witness scratch on there, and it does. It's just a little nick, and that's what I was looking for, that little nick. Okay, so this is set correctly now, and then what we can do is we can just, to work that radius, we're just going to advance this in until we land on the arc center number, which is 750 in this case. Okay, so we can just work our way in little bites at a time until we reach the correct depth, and we'll have the right radius at the correct depth, and we're done. So anyway, that's how you set that little guy. So let's go ahead and start whacking on that. Make sure I'm in back gear there. A little lubrication. Okay. All right, so then I'm just going to advance it some more. Yeah, let's go down to 800, something like that, and continue on. Let's see if we can zoom this. Okay, so we got the little clamps here, and you can see how those work now. Something when I was kind of trying these on here, something I realized here. Originally, I was going to have these facing off of the, the rear of the jack, so that your toe is going in that direction with the handle. And then I was putting them on here, and I realized that this actually fit a little bit better on the side. The distance from the jack cylinder to this edge is slightly different on this side, and it actually kind of works better this way. I was going to have to notch this out anyway for it to sit down, but here it goes all the way to the bottom, and it's fine. And also, I realize what's going to the side benefit of that is when you're up alongside of whatever you're lifting, instead of having the handle project out this way. So you actually reduce the operating space for this, which I think is a bonus. So anyway, there's the clamps that clamp to the jack body. Here's our bronze guide. I just made that off camera. There's nothing magic there. So we'll put this together and kind of do a dry fit. Okay, so and then this goes this way. So you're starting to get the idea, I'm sure. This is just a trial assembly. So now this is sitting down nice, and you see that's just basically right up against the jack, which is wonderful. And then here's the moving part of it that interfaces with that bronze key right there, and that'll go up and down. Here's our foot, and then this will be cut out for this to sit down in flush like that. Back here though, something like that. Okay, and then this is the, can you see that up there? Yeah, I guess you can. Let me tip that up just a little. And then this is the part that'll connect to the jack here, and you can start to see how this is coming together here. So I still have to put some grooves or some teeth in that. I'm still thinking about what I want to do on that. I don't want it smooth. And then this will get cut out here. And what I'm going to do is very carefully clean up this cast iron here, and I'm going to use some silicon bronze, and I'm going to tack weld the jack to this plate, far away from the cylinder, hopefully. And so that'll keep that in position, and then this steel will get welded down to here also. So that's how the jack assembly mounts to this plate. And anyway, so we got one more episode probably to finish this thing up. I'm kind of tired right now, so I'm going to take a little break and come back to this in a bit.